right, to do your project, you're first going to start with the ruler on the centimeter side, Jordan, on the centimeter side. And we're going to measure in, starting at 0. It is a little hard to see where my actual centimeters are. I can see good, though. You're going to edge about 15 centimeters. So put a little dot up there, 15 centimeters. And then measure in from this top corner 10 centimeters. Does not have to be 100% accurate. We're just approximating, okay? Then I need to find out where they overlap. So about here is where they cross. So all I need is a dot where they cross. I do not need any of this other stuff. I'm just going to erase that because that's going to get in the way of my amazing art project. Okay, now comes the note card that I gave you. Now these were note cards that I cut in half. They are not perfectly cut in half. You have to figure out which side was actually the cut side and which wasn't, because we're going to use the non-cut side. What I would suggest you do is just take the corner of the paper and line up the corner of the note card. And like when I line up this corner of the note card, I can tell this is not the 90-degree angle. I can tell it's not because it does not line up perfectly on both sides. So maybe I line up a different corner, and when I line up this other corner on both sides, it lines up perfectly. So I'm going to label this one. This one's the 90 degrees that I'm going to be using. Okay, just make sure it lines up perfectly on both sides. Because what we're going to do is we're going to do a project that actually involves constructions, but because we're not going to be in school tomorrow and just timing, I cut out the construction part, so we're going to cheat a little bit. But it's still a really cool project. So we're going to actually use this for making 90 degrees instead of using a compass. Okay? So what you're going to do next is take your ruler and your centimeters, and you need to measure 2 centimeters on each side of this 90-degree corner. You see how I made a little dot on each side of the 90-degree corner where 2 centimeters would be? Measure 2 centimeters from the corner and make a dot. You're taking your corner, you're lining it up, and you are finding 2 centimeters and making a little dot there at 2 centimeters on the very corner of the paper. It's not the corner in 2 centimeters. Are we okay so far, or do I need to slow down? Okay, you want to do this in pencil just in case you have a mistake. I'm doing it in erasable pen so you could see it better, but it is erasable just in case I make a mistake. Also, you are going to have to do some math. So you probably want a separate sheet of paper for the math part. So if you want to grab out a separate sheet of paper that will be part of this project but will not be on the pretty part of the project. Well, it's going to be a pain in the butt to keep flipping it, but sure. I'm going to do this.
I'm going to look at the videos.
We have 15 minutes left of class. Mm-hmm. Okay, so what I'm going to do with my little 90-degree angle, where I measured the 2 inches, is I'm going to put where the dot on the paper and one side of that 90-degree angle, I'm going to put where I drew that dot, I'm going to line it up with my 90-degree angle, and I'm going to draw 2 sides, using this as kind of like a tracing template. I'm going to draw 2 sides where both sides are the same length. I'm drawing an isosceles right triangle. So I'll move it away. You can see what I did. I used the dot on my paper right here. This is where the dot was. And I drew a right angle. You don't put the corner on the corner. Nope. So I'm trying to show you like where my 2 centimeters was. That's the bottom of the triangle there. Okay, and then I will take my straight edge in a moment and I will connect this to actually make a triangle. I just don't want to do that until everybody's seen this. Yeah, you can do that. Okay, so then I'll go ahead and mark the 90 degrees so I remember that was the 90 degree. And I will connect the 2 corners to complete that triangle. That triangle is an isosceles triangle. So I know that these 2 sides are the same. I also know that they are 2 centimeters, but I'm not going to call them 2 centimeters. We're going to make it even easier for you. I'm just going to call them 1 unit. So that's going to be 1, and that's going to be 1 unit. My 1 unit happens to be 2 centimeters long, but that's okay. I'm going to call it 1 unit. So now what we're going to do on our separate piece of paper is we're going to do either Pythagorean theorem, or maybe this is a special right triangle. We're going to find the hypotenuse. Not using that, using 1, 1 as my 2 side lengths. I'm going to use the 1 and 1. So would you like to do Pythagorean theorem, or is this a special right triangle? What kind of special right triangle is it? 45, 45, 90. So if this is 1 and this is 1, what is the third side? 1 square root 2. I'm just going to write square root 2. Okay? That's all I have to do for that triangle. Now I'm going to make another one, but this another one is a little different. I'm going to take the 90 degrees, and I'm going to put the 90 degrees at the top 45 of this first triangle. I'm going to put the 90 degrees, I'm going to line it up with the hypotenuse, and I'm going to draw just one side. Okay, this is what I did. I just drew one side. The other side was the hypotenuse. I just drew one side, and that side is 1 unit. So all of these, every time I draw, every time I use my template, it's going to be 1 unit. Okay, so then I'm going to use my straight edge, and I'm going to take the corner, and I'm going to connect it back to my original starting point. I should have a 90-degree angle where my card was. Now, we're either going to do the Pythagorean theorem, or maybe this is a special right triangle, but we have to find the hypotenuse. So if I have a 1 as the shortest side and a square root of 2 as the medium side, is that a special right triangle? It is not. So how do we need to do this one? What's it called? The Pythagorean theorem. A squared plus b squared equals c squared. So the 2 sides of my second triangle are going to be 1 squared plus square root of 2 squared has to equal c squared. So my 1 side and my square root of 2 side, square them, add them together. Let's see, we get 1 plus, and then square root of 2 squared is what? 2 equals c squared. So I have 3 equals c squared. So what does c equal? The square root of 3. Plus or minus, but I'm going to reject the minus. Okay? So this is square root of 3. So now we're going to, again, take that 90-degree angle, and we're going to put it on the outside of that triangle where that last side was. And we're going to draw a new 1 unit side out there. And I'm going to use my straight edge and connect it back to the original point. Now I am going to have you finish doing the math of the hypotenuses. I'm not going to do all the hypotenuse math. That's the actual math for the project. I'm just going to make a couple more right triangles so you can get an idea of what you're doing before you leave. And it will end up being a spiral. And I have some done examples to show you, but you have to discover it for yourself. So like the next one I would do, I'd set up that 90 degrees here, and I'd connect. Well, huh? If you see a pattern, no. You can just write me about what your pattern is. Describe it. Okay, so I started doing this. You're going to see that the hypotenuse is going to change every single time. And eventually it's going to make a spiral. So I have projects from students in the past that I want to show you that you're going to do with this. And then you'll have a separate sheet of the math. And that's what the total project will be. If we're not back in school after spring break, you'll probably be submitting this to me via Canvas somehow. Okay? So, here or not. But here's a project that somebody did in the past. And made some sort of, I don't know, reptile. I'm hiding the math. Again, I'm math, that's why I'm going fast. Yes, the math that you have to figure out. Maybe, but from two things. Yes. Pretty is that one? You may ask a question. I'm still recording, though. I cannot answer that. You have to figure it out. I have good ones here. I also have not so great. First one was pretty artsy. Yeah? So when you're done, I should see your answers on the figure itself. I should see the hypotenuse answer and artistically created. Online, there's examples of other people's. Get that one? Nike swoosh. There's some examples of other people that have done this online, but I creative and think, where do you see spirals in real life, like somebody saw Gary? Yeah, and you can make it look like that, or you can just go crazy and decorate it fun like this person did. Okay? But you're not going to want to copy somebody. You want to do your own thing. So you notice it, and then the math goes on a separate paper with the exception of writing your hypothesis project.